Hey there, I am BogdanBudaca and welcome to my channel. Thank you for joining me for another mind workout. I hope that you're staying indoors and that you keep safe and you keep learning. Today I thought we could go over another cool little problem. We will be computing the readability of a given text. So of course, whenever you feel that you can continue on your own, please pause the video and do so. And yeah, we can dig right in. I already have some notes ready here so we can get started easier. And yeah, the mission is to compute the approximate grade level of needed to comprehend some text. So this is handy if you want to know the difficulty level of a given text. And this is based on the US education system. And we have grades 1 to 16. What's lower than grade 1, we would just output before grade 1. And what's equal to or greater than 16, we will output grade 16 plus. Okay. This is done with the help of the Coleman-Liau index. You can look that up online. Very interesting. Basically, it gives us an equation that we can use to get this index, and we already have it here. And basically, it looks at the number of words and the number of letters and the number of sentences, and then actually the number of letters per 100 words and the number of sentences per 100 words, and it approximates the difficulty level of that text. Okay, so this is the equation. L is the average number of letters per 100 words in the text, and S is the average number of sentences per 100 words in the text. And here we have another couple of small equations for letters and sentences. This is for getting the average per 100 words. And I already have some examples ready here. So yeah, we can dig right in. So how can we get this done? Well, maybe you've seen a hint in my browser, because I've been looking that up, preparing for this. But yeah, we could actually use the ASCII codes. Our string will be an array of characters. Okay, so basically we could iterate through those characters and look at the ASCII codes of the characters. Okay, and what I mean by that is, and we will ignore some cases. So we will ignore numbers, and for sentences we will count as a sentence anything that ends with a period, an exclamation mark, or a question mark. Okay, so we will be ignoring for example periods mid-sentence that are used, for example, for Mr. or Mrs. or anything like that. Okay, so we will be ignoring numbers as well. So we'll just be looking at uppercase letters, lowercase letters, the space character, and then question mark, period, and exclamation mark. Okay, so for example, talking ASCII codes, if our character has an ASCII code greater than 64 and less than 91, then that means that it's an uppercase letter. Okay, the same for lowercase. If the ASCII code of the character is greater than 96 and lower than 123, then that means that character is a lowercase letter. Okay, so we could be using this to help us get this done, and we can start typing out a small little algorithm for this. So step 1 would be get the number of letters, that's letters, get the number of words, and then we could get the number of sentences, that's sentences, and then calculate the index. Okay, so going down here, by way of letter ASCII codes, here by way of the base ASCII code, and here by way of the, I'm just gonna spell them out, type them out, so period, exclamation mark, question mark, of the ASCII codes. Okay, so yeah, we could get started and hammering away on our code. So let's set up over here standard.io.h. Okay, our main function. So let's initialize our chart text, our array of characters. our string. So let's just imagine let's give it a limit of 500, and here, so get input text, and here let's use a do while. So we'll try to stay away from no inputs. So do while, and here printf input text, and here we can use the fgets function, and it takes 3 arguments: text, size of text, and standard in. While we need to use the string library, so we can use strlen, so string length, while strlen of text. And there's a small catch here. So whenever we use fgets adds a new line character. So even if you don't input anything, the string, the array character will have its length will be 1. Okay, so we need to watch out for that. So I'm just gonna deduct 1 and compare that to 0. Okay, so let's see if this works. Go to the readability folder, GCC compiler, readability, not put this to readability. So it compiles, readability. Oh, okay, so it works. It will keep prompting us as long as we don't input anything. Okay, so moving on, next order of business is get the number of letters by way of letter ASCII codes. Okay, so I propose that for each of our steps to get the letters, the words, and the sentences, the three data types, the 3 data that we need for the equation, I propose we do a separate function for each, so we will keep our code tidy. Okay, so I'm not sure, maybe it will be a huge text, so I'm just going to use longs everywhere. Long calculate letters, and we'll receive argument is an array of characters. Here let's initialize letters 0, and let's start looping through our characters. So let's initialize long I equals to 0, I is less than strlen of text, and then increment I. Here we can have our if check here. So what were the numbers? Oops. So for uppercase letters we need greater than 64 and less than 91. Okay, so 64 text of index I and text of index I less than 91. Is that right? So 64 and 91, right? Okay. So this will be the first condition, and then or we can actually copy this out, so it'll be easier, and we will check for the lowercase characters. This needs to be greater than 96 and less than 123. Okay, 96. Oh, 90, 96 and 123. Okay, so if this checks out, we increment letters. Okay, and down here we return it. Okay. Okay, I'm gonna put this up top for our compiler to see it here. Okay, and actually, so next would be words. You can actually copy this and reuse it. Create the words. And here, words. Okay, words. Our check here will be different. And there's a catch here. So if we initialize words with 0, for example, imagine that we input test space test. Okay, So we will have one space, so we will basically get the output of one word, but there are two words, okay? So when we encounter space the first time, there's already one word there, okay? So we will initialize words with 1. Here we need to check for the space character, which is 32. So we're doing the exact same thing, we're iterating through the characters, and here we check if text of index I is equal to 32, so that means that's a space there, and we will increment words, okay? Then we return them. Gonna put this up top as well. One important thing here, so when we check for these for the ASCII codes, you can see that we're comparing with integers, so our code automatically casts the character to its ASCII code integer, okay? So maybe that's an important note here. So when we're doing this, when we're checking against integers, we're actually casting the character to its ASCII code integer. Okay, so that's how it works off the bat. We could, for example, use casting here, but that's not needed because the code does that automatically for us. Okay, so hope that makes sense. So here we got the words. We have it up top. So go here, run the functions, long letters equals to, just gonna this. So we will actually run our function and pass it the text, this, because we're actually passing the argument. Long words equals to calculate words, passing the text. So we're starting to get our values here, and we have one more, which is the sentences count. Calculate the sentences. This. So 3 places where we need to replace it. So initialize it to 0, we start looping, and here our check will be different. So we will have 3 checks. I can just reuse this and then change the values. So we have exclamation mark, that's 33. We have question mark in period, period is 46, and question mark is 63. Okay, so 46, 63. Okay. Okie doke. Let's see if we have that right. 33, 46, and 33, 46, and 63. Okay. So we're good. And then if that's the case, so if text of index I is equal to either of these, we increment sentences. Okay. So that should be it. Put this up top. So now we have our 3 functions. Get the letters as well. Sentences equals to calculate sentences, pass in the text. Okay, so run the calculations here. What do we need? Actually, you know what? I'm gonna copy these over so we wouldn't have to switch back and forth and toggle between these files. Just gonna have this here for a moment. Okay, so first, and now if we're going to these calculations using float numbers, we will be using float data types. Okay, so float calculated. You know what? I'm gonna keep using the snake case if we started this on this route. Calculated letters actually equals to, here we need this value 0.0588 times letters here divided by words and times 100. Okay, so we have the equations for these here, and I'm just inputting this value as well. Okay, so and if we're doing this here, we actually need to explicitly cast a float to at least one of the values, so we'd have correct calculations. So this is the calculated letters. This is the calculated sentences. Here we have this value. Okay, float sentences divided by words times 100. Okay, so float index equals to, what do we have? We have calculated letters. Oh. Minus, even it's not defined. Sometimes this, I think it's the ID, I'm not sure, but it does this. So just play with it a bit. Float x calculate minus. Oh, there we go. So it's all cleared now. Minus calculated sentences minus 15.8. Oh, there's an issue here. Version must have integral type. The same issue. Sentences. 8. I think it's the ID. I'm not sure. Calculate. Oh, that again. Not seeing it. Reason. I just have to play with it a second. Bear with me, please. Usually it works in the end. Calculated sentences. Doesn't have letters here. There's a different color. Okay. How long? Something weird's going on. I don't know what it is. Okay. This. So times letters. I'm just gonna turn back a bit. Keep this like this. Let me get this and try something else. Float letter count. So this seems to work. Letter count minus calculated sentences. I don't know why this happens really. Minus 15.8. Okay, I'm gonna use this one. Oh, funny. Okay. Okay. Okay, but we're using the letter count, calculated sentences, and 15.8. Okay. And one more thing we want to do is round up the value. So we need to use math library, math.h, and here int grade round. Here we will have int. Okay, I don't want to lose too much time on this issue. I don't know what's going on here. It's something about the ID or the compiler. I don't know. Actually, no, it's the ID probably, because we're not in the compiler yet. So yeah, I'm not sure what's happening here. One more time and that's it. Okay, so it seems to be working now. And see if we can use the other one, at least have this similar sentence count. Okay, so let's just use this. Okay, seems to be working now. Sorry about that. Okay, so we have our grade. So if we can start checking here, so if grade is lower than 1, printf, and here we can use what we have ready for grade 1. For grade 1, else. Oh, it's actually else over here. Printf. We have grade just add a new line here. Grade. Oh. Else if grade 16 is less than or equal to grade, we will output grade 6. Okay. Too much. Grade 16 plus. Okay. This else. I'm gonna move this. So move this here. Now and here we will actually pass the grade. Okay. Output. Okay. I hope this will work. We need some semicolons here, otherwise C won't like that. And I hope this is it. So I hope you were able to follow along. Let's just see if things compile. So we need to pass this option to link to math library. So that compiled. Let's run it. And now let's use some of the values. So some of the examples for grade 1, that looks okay. This one is grade. Oh, I wasn't running it, sorry. Grade 3. Okay, let's 8 goes. Grade 8 seems to be really working fine. Let's get a big one, grade 16 plus, and run it. Input grade 16 plus. Missing here, which is the new line. Okay, so this should be it. So again, we got the text from the input. Then we have our 3 functions, one to calculate the letters, then the words, and then the sentences. We just iterate through the array of characters and we compare with ASCII codes. And based on that, we actually get the count. Then we actually use the functions, we get the counts. Then we just plug that into the equation and we get the index. In the end, we round this up because we wanted to have an integer, and then we just output based on a few conditions. Okay, so this is pretty much it. I'll also upload the code to GitHub, and yeah, I hope this was as much fun for you, as it was for me. And of course, if you found this video interesting in any way, please give it a like and subscribe. And yeah, I'm looking forward to your comments, and I'll see you around.